Hello class, welcome back to witness class. Now you can see I have questions under alternative current. This is one topic I desire to, explain, expatiate so that you can understand. But because of want of time and the exam is already on, and some of you have the exams tomorrow and so on and so forth. So I will believe that by solving questions, okay, by solving questions you will be able to understand a lot under this topic, okay? So there are other aspects that is not covered by this question, but let's just believe God that the question that will be coming your way will look like something, alright, something like what you are seeing on the board now, okay? So now look at this question, okay? Now the first one, I hope you can see the board, yes. Then now the first one is there's a diagram, and this diagram, alright, you have to use this diagram to solve question 1, 2, 3, 4. Okay? You have to use the diagram to solve question 1, 2, 3, 4. Alright, so let's start with the first one. Now, can you see this diagram? What you are seeing here is what? Alternative current. So what is alternative current? Okay? So I would advise you to pause this video at this moment and take note of all these questions before we start solving it. Okay? Alright, I hope you have done that. Alright, now what is alternative current? Alternative current is a current that is what? Alternating time, okay? So we have a sinusoidal graph which represents alternative current. So I usually say alternative current is a current whose function is sinusoidal. Alright, can you see that? The current is alternating, and this alternation, the frequency of alternation is very high, at least 50 turns per minute, okay? So that's just a simple diagram to explain this alternating current, okay? So now, in an AC circuit, you could have an AC circuit mixed with resistors, capacitors, and inductors, okay? So now, this AC circuit you are seeing, we have a capacitor there, and we have a resistor there, okay? Now this is the source, okay? Now, the question, let's go. The question says, the impedance of the circuit is, what is impedance? Impedance is the word that refers to what? Hindrance, okay? Or resistance to current, okay? So impedance covers for both, what do you call it? Capacitor and resistor. For resistor you say resistance, right? For capacitor you say reactance, right? So the resistance of the flow of current in the capacitor is called reactance. The reactance of the capacitor. Why this one is called resistance? So when you have a combination of capacitor, resistor, and inductor, the total or combined opposition to the flow of current is what we call impedance. I hope you understand that. So impedance is what? The resistance or opposition to the flow of current offered by a combination of what? The capacitor, resistor, and inductor in an what? AC circuit or RLC circuit. I hope you get that. So how do we calculate this impedance? Alright? Now this impedance is calculated using a special formula. So impedance is represented by Z. So Z is given as square root of what? R squared plus the reactance in an inductor minus the reactance in a capacitor, all squared, as simple as ABCD. Now the question is, do we have reactance in inductor? No, all we have is reactance in capacitor. So we're just dealing with 1, 2. Okay, so let's quickly solve this. Do we have reactance in capacitor? This is not the reactance in capacitor. This is not the resistance. This is just the capacitance of the capacitor. So we are going to use the capacitance of the capacitor to get the reactance in the capacitor. And the formula to get that is reactance in the capacitor is given as 1 over, can you see that? 2 pi Fc. 2 pi Fc. That is the formula for what? Reactance in the capacitor. So 1 over 2 pi, okay, times F. Now the F is what we were giving here. This is frequency of the oscillation in this AC circuit, and this is the voltage. Okay, so the frequency is 250 per pi. Alright, so 250 over pi. What else? What else are we looking for? Capacitors. The capacitors is what? 5 microfarad. So 5 microfarad. You know, microfarad is 10 power minus 6, right? I hope you get that. So this pi will cancel this pi here. Alright? So 2 times 250, that will be 500. 500 times 5. 500 times 5, that will be what? 2,500, right? So what we have now is 1 over 2,500. Okay? Then times 10 power what? Minus 6. Where is it coming from? Micro. Micro is 10 minus 6, okay? So move that micro up. What you have is what? 1 million. Alright? When this one moves up, it becomes plus 6, right? So that will be 10 power plus 6. So 10 power plus 6 is the same as 1 million, right? 1, 2, 3, 4, 5, 6. So 1 million divided by 2500. So this 2 0 will cancel this 2 0 here. 25 here is 1, 25 here is what? 4. Are you seeing me? You know I'm solving this thing now. So 4 times 4 will be 0, 0. That will be 400. So 400 ohms. Okay? 400 ohms. So you take your 400 ohms and put inside this formula. So impedance therefore is what? Square root of R. What is R? 300. 300 square plus 400 square. That will give you what? Square root of 900 what? That's what? 90,000 plus what? 160,000, right? Okay, when you add this 9 plus 16, that will give you what? 25, right? So at the end of the day, I have this square root of what? 250000. Square root of 250000. That will be what? 500. 5 ohms. The impedance is, sorry. The impedance is what? 500 ohms. Did you see how I did my calculation properly? So 500. Option C. Can you see that? So you gotta permit me to clean this part of the board, okay? So that I can solve the next question. Okay, I'm using the diagram, right? Wow, the diagram is very important. Okay, let's not clean it. So I hope you've taken this down. I want to clean this part of the board. So that is what? 500. So let's solve the next one. Now the next question says the current through the circuit is. Now we're looking for current that will be flowing through the circuit. Now how do you get the current? First of all, you must understand very, very fundamentally that V is equal to IR from Ohm's law, right? Now this time around, we're not dealing with ordinary R. We're dealing with the total resistance. This is total impedance, right? So V is equal to what? IV. Are you getting me now? So Z is already given as 500, which is what we calculated earlier. Why I is what we're looking for. So I is equal to V over Z. So Z is the what? Root mean square voltage, which is 200. So 200 volt over what? 500. This 0 will cancel 0. 5 into that's 0. What? 0.4 ampere. 0.4 ampere. Option what is that? Option B. Can you see how easy this thing is? I hope I'm explaining it very well. Okay? So now we're going to solve the next question. It said the voltage across the capacitor is. Now we're looking for the voltage across this part. Okay? Now it is the combination of this voltage and this voltage that gives you the total voltage 200 volts. So how do we get the voltage here? Now listen. This voltage, you know, is in form of what? A vector, right? And when you have vector, you know how we calculate vector, right? Why? I know you want to know why. Why is it a vector? Because the voltage of a resistor is just this way, alright? It's in the same phase with the current. The current goes this way, alright? Then the voltage of the capacitor is lagging behind, so it went that way, okay? So the total voltage is now this one, alright? So when you do your resultant vector, you know what that one will give you, okay? So now, with the knowledge of this, what we do is just that the total voltage, which is 200, square equal to what? You know what I mean now. 200 square is equal to what? That of resistance, which is what? The voltage of resistance. Are we getting that? Okay, we don't have voltage of resistance. Okay, let's just say voltage of resistance square. Now the voltage of what? Across the capacitor. Can you see that? So now, let's get the voltage across the resistor.
No.
Alright? Let's get the voltage across the resistor. The voltage across the resistor is very simple, which is V equal to IR. So what is I? I is 0.4. What is R? R is 300 times 300. Remember, V is equal to IR. So I is 0.4, current is 0.4, R is 300. When you multiply it, that will give you what?
This one.
120 volts. Okay? So put 120 volts here. It means that VC square, voltage across capacitor is what? 200 square minus what? 120 square. So you know what to do now? You do your calculation. Square root of 40,000 minus 14400. I get. So I will press calculator and get this. I will press calculator and get that. So let me clean this part. I'll leave the diagram. So now if I clean this part, I will have that 400 minus 144. What is it in it? 6, 5, and 3, 2. So 2 5 right?
Yeah.
So V is equal to square root of 25600. Isn't that?
You wait up.
I have square root of 256. That should be 14 and it. Is it 14 or 16? Square root of 256. 16, right? So the square root of 256 is what? Square root of 256 is 160 volt. 160 volt. So what option is that? I put in it. Wow, I click the option. Jesus, 160. Oh my goodness. I don't even know what price is correct. Do we have 160 in that option? Let me check. Yes, we had 160 option B. Alright? You always click back to see your option. So option B is the correct answer there. 160. So now let's look at this. The last question under that diagram. It said the average power used in the circuit is average power used. Simple. When you are calculating power in AC circuit, you do like that. Power is what? Power is IV, I get me, but you're going to do it in terms of the resistance, okay? So that's what? I square Z. In terms of the impedance, I get me now. So what do we have? What is the I? The I is what? 0.4, right? Square. I mean times Z is 500. So 0.4 square is what? 0.16 times 500. So 5 times 16 will be 80. 80 watt. Option what? Option B, 80 watt. I hope you understand that. The power is calculated in terms of, the average power is calculated in terms of what? The impedance, not this one, okay? Alright, so now, we can now work on this part of the book so that I can solve other questions. Number 5. The peak voltage of a 100 volt root square main supply is. So we have a volt, a root square volt, 100 volt, okay? And we are looking for the peak voltage. So we need to understand root square and peak voltage. So what is peak voltage? You know, when I do a diagram of a sinusoidal wave, which represents my alternating current, this maximum point for either voltage or current is called maximum voltage or maximum current. Are you getting me now? Alright? So the root square is just what we call a steady amount of voltage or current that will produce the same quantity of heat in the same time in the same resistor. Please take note. The same quantity of heat in the same time in the same resistor. That is just root mean square. And it's more like, should I say average? But this is the formula you need to do that calculation. That the formula for root mean square is root mean square voltage or current is what? V naught over root 2. This is that. V naught over root 2. Everything like that. Okay? So V naught is actually 1 over root 2 is actually 0.7 alright, or whatever you have in your calculator. So we are looking for what? Peak. So this is what we are looking for, right? So we just cross multiply, right? So V naught is equal to V root mean square, right? Times what? Root 2. So V root mean square from the question is what? 100. So 100 times root 2 is what? 100 root 2. Right? That is the correct answer. So where is 100 root 2? 100 root 2. I have pressed calculator. What is the value of root 2? Let's see. What will be your value of root 2? The answer is what? I didn't get that. Is that is what? 141.42. Vote. Is vote, have you? Vote. So approximately that's 141. So which is 141 inside this option now? We have 141. No, we don't have 141. Alright, but you get the calculation, right? But we're supposed to have root 2, press root 2, let's see. Root 2, what that is? Root 2 is supposed to be
1.4142.
Why is the option not there? Alright, that's just the basic understanding of that. Okay, let's take the next one. You can always interpret whatever is wrong from this, but this is just a simple explanation, okay? So now, number 6, the peak value of the PD in the AC circuit. The peak value, we are looking for peak value of the PD in an AC circuit. Is 240. So V naught is 240. Right? Are you getting it? The instantaneous PD at 1/8 of the cycle is. So we are looking for 1/8 of the cycle. One cycle is 2 pi, right? One cycle is 2 pi. So 1/8 of the cycle is more like 1/8 of 2 pi. 1/8 of 2 pi is pi over 4. Are you getting this? A pi over 4 is more like 90. 90 degrees. So the question says, so what would be the PD at this instantaneous, what do you call it? Instantaneous, instantaneous voltage. So that one, instantaneous voltage, let's say Vi is equal to V over sine phi. Okay? So the angle of phasor difference of phase angle is what? Pi over 4, right? So that's what V naught sine pi over 4 is like 180 divided by 4. That's 45, right? 45 degrees, isn't that?
Yes.
Alright, sine 45 is root 2 over 2. So this is 240 times root 2 over 2. Please take note, sine 45 is root 2 over 2. So this is how we calculate this. So what would this be? 120 at this, 120 root 2. So this is your voltage at that instance. At that instance of what? 1/8 of a second. I hope you get the explanation there. So the next question is at the other side, okay? So let me try and clean this upper part. Then I can answer the next question. Yeah. No, it's not there. At home, I'll bring it later. I'm having a class online. So number what now? Number 7, right? So number 7 we have in the question series the PD at a phase angle of 90. So in this same question, what would have been the PD at a phase angle of 90? Now when the phase angle is 90 degrees, 90 degrees is like at the maximum. This is 90 degrees here, maximum. So it's the same as saying what is the maximum whatever PD or potential difference. You get it? So I don't need to do any calculation. What is the 90 degrees? Now I did the math. What is the 45? You know, 45 is half of 90 degrees. Now, alright, so what we have at 90 degrees, what we do? If you want to use the formula, you get the same. If you don't want to use the formula, fine. At 90 degrees, that's the maximum. Just put the value. That's 240. The answer is 243. But if you still want to apply the formula, what you do? You just do your instantaneous voltage equal to what? V naught sine what? The phasor is what? 90 degrees. So that would be what? That is 240 sine 90. This is first sine 90. What do you get? 240 sine 90 is still the same thing. Because sine 90 is 1. Did you get that? Sine 90 is 1. Is that correct? So now, let's try the other one. Let's try the other questions, okay? So now, the number 8 question says, an inductor of inductors 10 millihenry. Now, the unit of measurement of inductor is henry. Okay, so what we are seeing here is millihenry. Milli means 1,000. Okay, so millihenry. So an inductor of inductors 10 millihenry having a reducible resistance is connected to what? 1.5 since there's 1 here. 1.5 times 10 to the power 3 hertz oscillator. So we are looking at what? The inductive reactance, okay? Remember I talked about when we have a combination of what? The capacitor, inductor, and resistor. We said it is what? It will experience what? An impedance, right? But for each of them, it is reactance, right? So we are now looking for the reactance on the inductor. So what is the inductance? Inductor is represented with letter L. The inductance is what? 10 millihenry. And I told you the meaning of milli is what? 1,000. So they are multiplying like times 10 minus 3, right? Henry. Okay? Now the frequency is this one here. 1.5 times 10 to the power what? 3 hertz. Okay? So we are looking for what? What are we looking for? The reactance. So inductive reactance is given as 2 pi Fs. So 2 pi times F, 1.5 times 10 to the power what? 3 times L is what? 10 times 10 to the power what? Minus 3. This question is quite simple. How? Because this one will cancel this. How? This is plus 3 minus 3. 10 is power plus 3 minus 3, that's 0. So those two are gone. So all we have left is what? 1.5 times 10. 1.5 times 10, that's 15. 15 times 2, that's 30. So that's 30 pi. So our answer should be 30 pi. But since your answer is not in terms of pi, you can now press 30 pi. Please press 30 pi. 30 pi, you get your answer. 30 pi. Who is that? 30 pi. So 30 pi is what? Press 2, 30 times 32 divided by 7.
That's 94.2857. 94.2857.
0.2857. Let us say 29. Okay? Oh. Okay, like 1.3. This is the answer. Can you see that? When we approximate, it becomes what? 94.3. Okay? So we have, now let's solve the next one. 9. Question 9.
I get down.
Okay, I clean it. I'm liking something I just saw now. What's happening with my hand? Please, you can pause the video to write. Now, I think this is the last question. Okay? And very interesting. Now we have RCL. This is a combination of all three factors in AC cycle. The voltage applied in the RLC cyclic diagram shown above it. So we are looking at the total voltage. The total voltage is not this plus this plus this. No. Yes, they are in series, two of us. Yes, they are in series. But remember, if they are behaving, you know, the addition of this is a vector sum, not a scalar sum, okay? Scalar sum is not a this plus this plus this. So the addition of this is a vector sum. And what is the vector sum? Remember that this one and this one, they are acting in opposite directions. The voltage is acting in opposite directions, so they will cancel out each other. This one, the voltage is ahead. The voltage of the inductor is always ahead. You can see in figure. The voltage of the inductor is ahead, while the voltage of the capacitor is lagging behind. Okay? So we are going to do this minus this. Alright? Now, also, anytime the voltage of L and C is equal, then we now say that RCL circuit is in a resonance. We call it a resonance circuit. A what? Resonance circuit. That is when the voltage of this is equal to this. Or when the reactance of this is equal to this. Or when the, you know, I'm getting it. Sorry, when the frequency, no, the frequency is the same. Actually, when the what, reactance of this is equal to this, the reactance of this one. When the capacitive reactance is equal to what? The inductive reactance. Okay? So to do that, the total voltage applied to this RCL circuit is V equal to square root of V for R, V of R squared plus V of L minus V of C. Remember, this one is ahead, right? Ahead, so you subtract them because they are in opposite direction, they will cancel out each other, right? So, equal to the V of this one is what? Just like what I did when I do this one. So the V of this one is what? The V of R is what? Plus square plus V of the L is what? 18 minus 13 all square. So what do you have? Square is 144 plus this minus this 5. 5 square is what? 25, right? So add it together now, 169. 169 is what? 13. So that is 13 volts. 13 volts. What is the answer? Option B. I hope by this simple calculation and examples you are able to understand, you know, an aspect of what? Alternative current. So the other thing you need to know is that now when you compare the current and the voltage of an RLC circuit, for a resistor, the current and the voltage are in phase. The current and the voltage are in phase. So this is current, this is voltage, they are in phase. This is for resistor. When is a resistor? Alright? This is only the resistor in the circuit, in the alternating current circuit. Now, but when you have a capacitor, the current is ahead of what? The voltage, capacitive voltage, capacitive current. The current is ahead of the voltage. For what? Capacitor, take note, capacitor. And it is ahead by 90 degrees. Or the voltage is lagging behind. The voltage is lagging behind by 90, or the current is ahead by 90. Either way is correct. Now for inductors, let me see this part of the board. For inductor, the voltage is ahead, please, the voltage. I see. Inductive voltage is ahead of the current. Inductive current. I see. So the voltage is ahead by 90 degrees, or the current is lagging behind by 90 degrees. For what? Inductor in an AC circuit. For inductor in an AC circuit. Thank you. I hope you have learned a lot. Please try to make comment on that video and subscribe. Thank you.